Let's investigate which hypothesis test to use for this study. A research lab wants to test if there is a difference in driving ability for drivers who are driving normally, driving while talking on the phone, driving while texting, and driving while using a map. They do this by dividing the 100 test subjects into 4 groups randomly and assigning them to one of the 4 driving methods. Each subject drives through the test course and is given a score based on their performance. A summary of the scores is shown below. Is there evidence that a driver's activity is associated with their performance? The first thing I notice about this problem is the word associated. That tells me that I'm testing an association, relationship, or correlation. So I should consider a method that's designed for 2 variables. We've studied 2 such methods so far this semester, the 2-proportion z-test and the 2-sample t-test. We'll learn more methods for 2 variables in the coming weeks. To decide between these tests, we should think about what the variables are. Recall that the explanatory variable is the variable we think is explaining the change in the other variable. It's often the variable that's known first or is easier to measure. Additionally, if we have a randomized experiment, then the explanatory variable is the one that was randomly assigned. The response variable is the variable we think is being impacted or changed by the explanatory variable. It's often the variable that's known second or that we'd like to predict. In this case, the thing that was randomly assigned was the driving method or activity, so that's the explanatory variable. The response variable is the driver's score on the test course. The problem gave us means and standard deviations for people's scores, which is an indication that this is a quantitative variable. The explanatory variable was categorical. It had 4 possible values: driving normally, on the phone, texting, and using a map. So it was categorical, but not binary. It had more than 2 possibilities. That means that this study doesn't fit with either the 2-proportion z-test or the 2-sample t-test, because of both of those expect the explanatory variable to be binary categorical. So no test that we've covered so far in this class is appropriate. In a few weeks, we'll learn how to use an ANOVA, an analysis of variance, which would be appropriate for this study.